All right. So, Key Club. It's a service club.
They know what it was. They explained it right after y'all signed the work club. I was like, wow.
No, Key Club is a service club.
I didn't even sign up for that. No one is valid.
Don't ask.
The ACC press.
How many manganeses do we have? How many chromium? How many oxygen? All right. What's the mass of manganese?
54.94.
That would have been fine. Chromium.
That's not accurate.
All right, and oxygen.
16.
Okay. Now, if I was doing this on paper for a quiz and test for lab tomorrow, I'd use the decimal place. But typically on the board when I'm just solving today, I would just use whole numbers. And when we do the empirical formulas in a minute, I will use the decimal. 109.88, 520.
Oh my God.
60 plus 520 plus. Did we get somewhere around 1190?
Yeah.
Okay. I know, I rounded up to 110. All right, so when we do the percent manganese, manganese has a mass of, I rounded up to 110 over 1190 times 100. So, again, from last week, this has no numbers associated with the question. It just said, what is the percent composition? So when you get your answer, do you have to round a significant digit? No. So I could round this to 9%. I could make it 9.2%. I could make it 9.24%. Any of those answers are fine. Or whatever close likeness to that answer you have. Okay? There's no wrong number of significant digits. Everybody okay with that? Okay. So when we do percent chromium, chromium is 520 over 1190 times 100. So somewhere around 43.6%. And the unit is percent, by the way. Somebody in 4th Street asked me what it was last week. So that's the percent. It's not very technical. So. And the last one, 47%. And that one I had 0.0 after it, so you put 0.0. All right, I tend to use one place behind the decimal, but you certainly don't have to. Questions about how to do percent composition? Everybody remember? Okay. Tends to be the most missed on the quiz and on the test. But it's just because people forget how to do it. Are we okay with it? All right, let's find our notes so that we can talk about percent composition. This is a new unit if you want to label it as such.
What was the call for?
Call it stoichiometry if you want. It really goes with percent composition, but it's called stoichiometry. I'll give it a title in just a minute. I'll spell it and give it a title. I'm going to give it one.
I thought that was the next one.
It is, but I have them split up, so. You can call it stoichiometry part 1 if you want. Yeah. I'm going to spell it in just a second. We just, we're talking about it. It's actually in multiple parts because all the stoichiometry we've done up to this date will also be on the next step. Not the reaction test, but the one after that. It's like a multi-part unit. For those of you who want a title, because I know there are some of you out there, it's spelled stoichiometry. Technically, it's part 2 because the stuff where we converted grams to moles to atoms and grams to moles to molecules, that was part 1. Okay? This is part 2. And we're gonna do part 3 after we've learned the balance equation. Right? So, part 2. Everybody have the title? Well, I need to erase it. Can't stay in the middle of where I want to write.
Why you got to? Why you got to?
I don't know. I don't know. I have no explanation. Well, I have no explanation. It just is. All right. What is an empirical formula? An empirical formula is also known as the simplest formula. I don't think that I get that.
No, it's right.
Oh, it was right at the bottom. Okay. All right. It's also known as the simplest formula. It is a formula that cannot be reduced. In math class, you might think of it as in lowest term. Formula that is in lowest term. But it's often called the simplest formula. So some questions might say, what is the simplest formula? Instead of saying, what is the empirical formula, it might say, what is the simplest formula? Now, for some examples, if you had a formula like C2O4, is that formula in lowest term? No. It could be reduced into what? All right, so CO2, this is the empirical formula. This is what we're going to talk about in a little bit. This is going to be called the molecular formula. We'll come back to it in a little while. Now, can every formula be reduced? No. For example, one that we talked about last week, Na2SO4. Can this one be reduced? No, because S has a 1 on it, right? Can we reduce a 2, a 1, and a 4? No. Since this one is already reduced, it is both the empirical formula and the molecular formula. We'll talk about what a molecular formula is a little bit. It's not important for right now. I'm just merely pointing out how they're related. Giving you enough time to catch up, or do I need to wait? If I caught up, then we can have a shot. Why on earth would I have that? Right. I said, if you look at C2O4, you see how it has a 2 and a 4? A 2 and a 4 can be reduced in math class, right? So that's not an empirical formula because it's not in lowest terms. CO2 is in lowest terms because there's a 1 and a 2 there. That's an empirical formula. Okay? This is a molecular formula because it's not in lowest terms. Okay? With me on that. This one, can I reduce a 2, a 1, and a 4? No. So that one is both empirical and molecular because it's already in lowest terms. We can't reduce that. Okay? All right. Now, we're going to learn how to calculate empirical formulas today. Step 1. I learn a lot today. Number 1. We're going to change percent to gram. Some problems will be given to us in percent, and some won't. If they're not in percent, we're going to skip this step. But a lot of them are going to be in percent, so we're going to have to do step 1. But if they're not, let's skip it. So convert percent to gram. Okay. Step 2. In order to work any math problem in chemistry, we have to change it to what? What I say,
That's what I said.
Oh.
every unit in chemistry has to be converted to what? There you go. Grams has to be in moles. You cannot change and convert anything in chemistry unless it's converted to moles. Now, this is the unit everything gets changed to in order to relate it to something else.
I still don't understand what it is.
Doesn't matter. The relevancy at this point you don't get.
I know.
It's okay. It doesn't matter. It doesn't matter.
All the molecules.
Think of it as all calories.
Yeah, like that. And then like.
The calories vary and everything.
A lot of calories. A mole is the simplest form for that.
Yep. And all the calories and all the cakes vary, depending on the size of the cake. It really does.
Like, okay, say for instance, yeah, okay, you have there's a cylinder of water. A water. And then it's like, you can't physically count all of these molecules in that water. So that's why. Yeah. So that's why. That's great. Hey.
You weren't doing a bad job, other than them picking on the way you said water. Now, divide smallest number of moles by itself. Now, in math class, if you divide one side of a math equation by something, what do you have to do the other side? You got
You're still proud of me for making 100 on the test.
I know, he was doing a fabulous job trying to explain moles. And then you think I'm stupid.
Am I the only one that does that same thing? Probably not.
Yeah, I call it.
Okay. But in my class, if you divide the left side of the equation by something, what do you have to do the right side? Divide it by that same number, right? So, if we divide one number by the smallest number of moles, we have to divide the other numbers by that same small number. And then, we're going to write the formula. Step 3 sounds complicated the way I have it written. Is not complex. We just divide. It's not hard. This is one of the easiest problems we do all year. And most people remember how to do this one all year. All right, does everyone have a chance to catch up? All right, we're going to do 3 examples. Yes, you need to write all 3 down. There's a twist to all. The first one is the straightforward one. The second 2 have a twist. Because certainly I would never put a twist on the test, would I? No, I would never do that to you. Why? Because it's fun. Now, here's the straightforward example. All right? So we have a sample. Some compound has 32.38% sodium, 22.65% sulfur, and 44.99% oxygen. And I want to know its simplest formula. Meaning I want you to be able to write its formula like you wrote on the test. Without the blue chart. Without its oxidation number. I want you to calculate its formula based on those steps. Sort of. Yes. The blue.
There's a Y in the end of it.
It has me. I know. She likes all the stuff. She stood there, she asked first, she gets stuff. Exactly. She has not smashed anything. If you put your hand through the glass, so I warn you, I'm going to be really sick. Although it should be shatterproof glass, so you should be safe. Even you should not be able to break that glass. Yes. All right. Everybody got it?
No.
The important part is the percents with the elements behind it. Okay, that's the important piece. Now, step one is to take and change the percent into grams, right? So how are we going to do that? Nope. No. No.
All of them divided by that.
Nope.
32 divided by 100. They talked about the,
Y'all make it hard. You didn't say exactly. Exactly. So I'm going to take my little eraser. All right, G.
man,
It's like, wait.
you breaking my.
You cannot do that. Like, it's not.
Where? Betty. If we added up all those percents, just out of curiosity, what do you think we get? So we're going to assume this is a 100 gram sample. And if it's a 100 gram sample, we're just going to erase all those percents and write what? Exactly. So it's that simple. Nope. I told you, it's one of the easiest problems in the work. We're going to erase percent and write grams. Step two, we all know how to do. What are we going to do in step two?
Converted to mold.
Convert the mold. So I'm going to draw a little chart on all three of them. So we know how to do this. It goes on the bottom. Very good. So grams goes on the bottom, what has to go on the top? And what do we know goes inside mold? Because we haven't learned to balance yet, we all know mold fits the one. Now, do I have a fancy compound in my chart? I got it. Just elements, right? So where do I find the masses if all I have are elements? Yeah, it's easy. I don't have to add anything up like formula mass. I just have to look up there and find their mass. Sodium is 22.9. Let me change colors. So sodium is 22.9. Sodium is 32.01. Oxygen is 16.
Oh, you messed up. That's what you.
I said sodium. That's salt. All right. So from there, what do I have to do? Okay. See if I can punch these in right now. I have a calculator error. Okay, helps if I don't put in straight symbols in the middle.
He knows right one of my favorites.
Alright, notice when I calculated my moles, I didn't round off to just one place behind the decimal. I took it out several decimal places. Fine?
Oh, there's a fourth.
I didn't worry about that, I just took it out several decimal places. If you round off too short of a number, there are a couple problems I have that you will round up, you will wind up wrong. So we just take it out at least 2 or 3 decimal places. Alright, so what does step 3 say to do after I found my moles? Okay, so divide by the smallest number of moles by itself. So which number is the smallest, Theta? 0.70. Alright, so if I divide by the smallest number, 0.7075, I get a 1. But if I divide there by the smallest number, what do I have to do with these two? There you go, divide it also by the smallest. Alright, so if I divide 1.413 by 0.7075, I get 1.997. What's that the same as? That's the same as 2. Alright, 2.811 divided by 0.7075, I get 3.97. What is 3.97 the same as? 4. That's a 4. Now, the last step is to write the formula. So, this 2 came from what element?
It's all 3.
So, Na has what subscript? The 1 came from what element?
Sulfur.
The sulfur has?
Nope.
Alright, and the 4 came from? So, oxygen has a?
Oh my God.
No.
It's sodium sulfate.
Yes, it is.
Oh my God.
Question.
No, my mind's blown. I can go home now.
Okay, I don't think Mr. Jessup will appreciate that. You need to stay. Alright, can we do one that's got a slight trick in it?
Yes.
Oh.
Not hard.
What?
Alright, write this one down.
I like to
Oh my God. Burger.
No, I know that. What's the move when I go
We
to
have to find like
Oh, no, I want you to just write that. We're gonna do it together, because it's got a trick in it. I was just looking at what I needed. Need to check out my magnesium reference. Alright, so do we have it?
No, I want to try to do it. I am
Oh, okay. So when Emma had hers, that was hilarious.
What did I do? And then last day, my girl took me back, I was like, oh, my hand. I keep talking. No one in my. I'm at home, so I said, asking something, I have to come back and back. But it sounds really weird.
All right, do we have it? All right, so in the first step, what are we doing?
Change the percent to grams.
Yep. So, grams, okay?
On the test. If you just throw grams down there,
It'll be fine. I would not expect you to, right? I'm just making sure you know to do it. All right. It's not like I'm going to be standing over your shoulder watching. All right, step 2. Exactly. All right. So, what goes on the bottom? And on top? Next 2 moles.
1.
All right. The mass of K is 39.1. Grams is 1.9. Mm-hmm.
I'm with the phone.
Alright, so, if you have these 3 numbers of moles, what's the next step?
Divide by the smallest.
Alright, so what's the smallest number? Alright, so 6.79, 0.679. Alright, so we get 1.679 here. And we get 1.00 something. 1.000. And then there was a 4 at the end. So that's the same as what? 1. Now, I want you to punch in this last one yourself. I want you to see what comes up.
Oh, you got a negative.
No, you don't get a negative number. How you gonna get a negative when you divide 2 positive numbers?
Oh!
I don't understand what you mean by getting bigger. It's bigger than 1, yes.
No. The number is bigger than 2.37.
Oh, yes, it is. It is. It is bigger, yes.
Is that like dollars?
No, it is completely not better. But it's okay. It's okay. I'll also go get what I'm looking for because I'm not reading. It's all good. Does anybody know what I'm looking for?
It's 3.5.
Yeah, it's not a whole number this time. Every other time you got something like 1.0, 3.99, 1.99. You got a whole number. This time you got a number that turned out to be 3.49 when you punched it in. Every other time you got a whole number. You do what when you get 3.49?
Round it down.
Okay, that's why we need to talk about this. You cannot round it down or up, okay? That's the trick to this one. This number that you just got is the same thing as 3.5. Okay? You cannot round that number down to 3. You cannot round that number up to a 4. No, we got to fix it. Okay? So, whether you think of this 3.5 or 3.5 doesn't make any difference to me. So, when we run formulas last week, you have a K with a 1, a CR with a 1, and an O with a 3.5. Did we write any formulas that looked that way last week? We're not starting this week. So think math class for a second. How would you get rid of a fraction of a half in math class? Multiply every single one by what? What's a half multiplied by half in math class? Shush. What would you get when you multiply half by half, Nada? What math class are y'all in?
All people came out of the university, and they got money like that.
Okay. A fourth or a half times a half is a 4. Okay. So you need to multiply by the inverse or the reciprocal of a half. Okay. So the opposite of a half is 2. So we're going to multiply by 2. Okay, because we're going to flip the half. So K times 1, 2 times 1 is 2. 2 times 1 is, so CR is going to have a 2. And 2 times 3.5 is 7. And if you don't know that, multiply it on your calculator rather than get the wrong answer on the quiz or the test. Because you'd be surprised at the number of people who multiply the subscript by 2 and give me some really weird number. Okay? It could be, but I don't know. But multiply it on your calculator to double check yourself, just to make sure when you multiply it by 2, you have the right answer. Okay? So you get K2CR207. Questions about that? You will only get a whole number or a half in my class. Now, if we were in AP, you could get a fourth, a third, a whole number, or a half. But given you're in a first year chemistry class that's not AP, you will get a whole number or a half. So if you divide and you get something down here that says 3.85 or you get 1.39, you should be concerned that you've done something with your numbers, because you're not going to get those in here. You will either get a whole number or a half. Yes. I have once, typically Chem 2 doesn't make. They tried to make it this year, but people asked them to scurry too late. So
You make one next year?
they asked them to scurry too late. I don't think she'd actually let me teach it. Just saying.
I want to take it.
All right. Last one, and then we're going to talk about molecular formulas. This one has a different trick to it. Write it down.
Yeah, I think I've done something.
I won. All of them get bigger.
They all do get bigger. Oh,
You multiply like that.
It's okay.
I'll be at coffee.
Okay.
wait for this. I still understand color last.
Yeah. You go here, you do, right?
Yeah.
Alright, so we got it written? Alright, what's different about this one as the last two other than it's a grade? Okay. I just said other than it's a grade.
We have the,
I know.
yeah, two options.
Last time, the.
Oh.
We assumed that was 100 grams. Thing.
Uh-huh.
10.1.
Okay. What else you got?
It's called phosphorus and oxygen.
Yeah.
One thing in the gram is phosphorus and oxygen, so two oxygen. Yeah. Oh, it's a compound. Yeah, that's what it is. Compound.
It's a polyatomic item.
Yeah.
What?
That'll probably help it out. Now Sheldon's the close. It is a compound, but he sort of stopped before he finished. You need to keep going. So he said phosphorus and oxygen is a compound. And what else do we know? The phosphorus and oxygen are compounds, okay?
Oh,
So what else do we need to know then?
that, what kind of compound is it?
I don't want to know what kind of compound it is. What makes this special or different? Okay, they're sharing grams, so we know that they're combined to be 10.150 grams, okay? So their mass is combined. That's the part that's different. Their mass is combined, so we're going to have to almost. There you go, not divide. All right. This,
Oh!
okay, that's the mass of oxygen only. So you have oxygen's mass is equal to 5.717 grams. They didn't give you a mass of what anywhere in the problem. They didn't tell you a mass of phosphorus anywhere. They gave you a mass of phosphorus, and oxygen is this thing. That's phosphorus and oxygen. But they didn't tell you phosphorus anywhere. They gave it to you combined. So, the only thing Tyshawn had wrong is he said divide, when he should have said what Daniela said, which is subtract them. Okay? That's the only piece you have wrong. So, we're going to take the mass that's combined, and we're going to subtract the oxygen to get a mass of what? 4.3. 4.3 what? 433. All right, and so that's your phosphorus. So, which two numbers do we need to set up in our chart? All right, so we need the 4.433 grams of phosphorus, and we need the 5.717 grams of oxygen, right? Good, y'all finish it. Find me the answer.
Like that?
Just like that. You set it up, y'all find the empirical point.
No.
That's it, that was the only thing. Figuring out that phosphorus was not given to you, you had to figure it out. That's the trick. Just finding the mass of phosphorus. It wasn't given. That's it. Now the problem works just like what we've already done. Okay, well then if I put that on the quiz bar, card out of bar Wednesday, you'd have been fine. Okay. Okay. So I wouldn't have been attacked if I put that on the quiz. You probably wouldn't have. If some people would have had a meltdown. Anybody have a question?
Yeah.
Yep.
Oh, wait. I don't think I need to check my answer before I say something there. Not loud.
Yeah. Oh, yes. Yeah. There you go.
Football team, check mine.
Yep.
I'm just kind of glad I have this last year, so I can get my comments out in a comfortable environment rather than my second year with yelling. But now I don't know.
Really, you gotta divide those two? Yeah. You don't have to divide those on the calculator. Now that's what I understand. Okay.
That 830.
Yep.
Martin,
Yep. Yep, we gotta do it half.
I know, but yesterday, this morning.
No, only when you're gonna have to pump up. We'll always done it. And this. But that yeah. Then you won't always gonna have. All right, do we get P205? Fabulous. All right. Huh?
No.
You can get P205?
I think that's I thought you were.
Yeah. If you multiply that by 2, you gotta multiply this one by 2 also.
Oh, okay.
That's why you get.
I didn't know.
You gotta do it, remember how in math class you did it to the left, you gotta do it to the right? So if you
I need to make a
multiply-
note.
So if you multiply that one, you gotta do that one too. The second half of your lab tomorrow / assignment will involve molecular formula. Gotta calculate these too. All right, so you're doing molecular and empirical formulas tomorrow. First part, we'll ask you to calculate the empirical. Second half, we'll ask you to calculate molecular, and then you're going to write their names. And I will give you the option tomorrow. You can choose to write their names in empirical or in old system or in stock system. You can choose. What's Wednesday? Today is Monday. Quiz is Wednesday. Tomorrow you're doing a lab assignment. And you can't use your notes. You get a partner, but no notes. All right? Yes. You got to know how to do it tomorrow. So you get a partner, but no notes. Now, molecular formula. All right? Perhaps I should choose your formula. Perhaps I should choose your partner. Perhaps I should choose to borrow. Dr. Phillips even showed me an app to use where it would randomly select your partner.
I'm good.
I consider that. I take that under advice. Yeah. A molecular formula shows the actual number of atoms. Yeah. Shows the actual number of atoms. Now, this formula may or may not be reduced. Okay? It may or may not be reduced. Because if you have a formula such as the one that we had on we had a quiz last week. I think it had this. No, it wasn't. It was nickel. It had nickel in it.
Oh, I know,
Had this. Okay? It had Ni2O4. All right, so if you had Ni2O4, all right, what did you have to do the Ni2O4 on the quiz last week? You had to reduce it. Okay? And so you had NiO2, right? So this was the empirical formula because it's in simplest terms. This is the molecular formula. This is one that could be reduced. All right, so it's in the may be reduced category, correct? Now, do all formulas have to be reduced? No. So if you wrote a formula like CaCl2, can that one be reduced? No. It's already reduced. Okay? This one is already in lowest term. So it is both empirical and the molecular formula. So this one is in the may not be reduced category because it's not going to need to be reduced. It's already in lowest term. Most of your ionic compounds are going to fit in the doesn't need to be reduced category. But there are some that will need to be reduced, like the nickel one that I chose. But a lot of them are already going to be in lowest terms. They're just simply not going to need to be reduced. A lot of your covalent compounds will need to be reduced. Hey, Ms. Farley, who you need? Who? Oh, you answer. Or think it's for you. Okay, could be worse. It could be in the third period. I have 2 Nathans and 2 Devons.
Oh, yeah, the
All right, does everybody have it? All right. Oh, I forgot. You need steps. All right, first of all, what things do you need? In order to solve this, you need 2 things. Number 1, you have to have a molar or a formula mass. Without that, you simply cannot do the problem. It has to be given. I shoot for that every day I come to work. Now, without the formula mass, you're dead in the water. It has to be given. The second thing you need is the empirical formula. Now, the first problem or 2 we're going to do, the empirical formula is going to be given. However, tomorrow on the lab, the empirical formula is not going to be given. You're going to have to find it first. On the lab we're going to do Friday, you're going to have to find it first. Okay? Then you can find the molecular formula. Now, yes, you do. The steps. You take the mass that is given, okay, which is essentially formula mass. You divide it by the mass. You add up. Okay? Which will be the empirical formula mass. Now, when you divide these 2 masses, you are going to get a whole number. A 1, 2, 3, 4, 5, 6. If you do not get a whole number here, you have done it wrong. This whole number tells you what the formula was reduced by. It has to be a whole number. You take that whole number, you multiply it by the empirical formula, and you will get the molecular formula. I'm always worth people back. That's good. The whole thing just well, molecule is Avogadro's number in relation to molecule. There needs to be some. There is a connection. You just don't like the connection.
I don't understand. You don't have to.
Yeah, this is not English
I
class.
don't like it.
I'm sorry.
This is why I love this class.
All right. Everybody got what they need? All right. Here's a standalone simple question. This is as easy as it gets. No tricks to this one. This is an easy one. There's really no tricks to molecular force. I would write both of these down. We're going to do the easy variety, and then we're going to combine them. Yeah. Yeah.
A lot of learning.
So we have to do it tomorrow without the notes.
Yeah. Hey, you get a friend. Well, you get a partner. You might not like it. This is behind it. I don't like you.
I like this.
I like
We're not, but you're not saying that like that's the way I think
Exactly.
Oh, yeah.
That is very nice. Is it right? You said what?
If I didn't like it, then it would be really that would be wrong.
That's a couple. You get right something else.
Me, I don't, well, no.
I don't like a lot of people, but I don't like I don't get like it. I just have like.
I have, oh, there is.
I did.
So it's well.
Alright, does everyone have an opportunity to write that?
Loud.
Oh, like
Listen to that, no, like, it's like work music.
Okay.
It's a loud personality. I just know a lawyer.
Yeah, I like it.
Real.
Oh, yeah, yeah.
I don't get enough attention at all. I'm always.
You're like a 112 kid or something? Then why don't you don't get enough attention at home?
I was kidding about that.
Oh, that's yellow.
Yeah, I feel like it's been talking and more done.
Alright, so what goes on the top line? A formula math. So,
I'm a middle child.
the math that's given goes on top, right? So what math is given? What's wrong? Alright, so 283.889 goes on top. What goes on the bottom? Math you add up. Well, what's the only thing we have to add up? The empirical formula. And if you look back at the directions, I told you the empirical formula is math, right? So, what is the empirical formula? That's what we're adding up. So, how did we learn last week to add up a formula math? So how many phosphoruses are there?
2,
How many oxygens are there?
5,
Okay. All right, so
30.
I'm going to use whole numbers just because it's faster on my math.
30.
31, 16, 62, 80, 142.
It's like 30.9.
It is. Why use 31? All right.
I know. You guys make me like forever, so. I just kind of
Okay, I can multiply a little faster in my head than y'all can, and I don't have to use my fingers to multiply. 2 times 31.
I think the add.
2 times 1 is 2, and 2 times 3 is 6.
Well, I think
Okay.
it's 31 times 2, but it's 16 times 5.
I just know that one is
You have to
80.
do about 30 seconds.
You gotta remember like.
Okay. 2 and 0 is 2. And 6 is 14.
Oh, I gotta do 6.
Oh, we got percent. Oh, shoot.
Okay. All right. So where am I putting 142 now? Okay. Now, when I divide, this has to turn out to be a what? Whole number. So 283.889 divided by 142 is 1.99999. So that's the same as what? That's a 2. Now, you might not get exactly a whole number, Ethan, but it should be pretty close, like 1.99999 or 3.999, something like that. If you get 3.75, you should be worried, or 3.89, you should be concerned. All right? 3.3, you should be worried. Your math is messed up somewhere. It is. Now, that means that the original formula, meltdown over there. All right? This means the original formula was reduced by 2. That's what that whole number means. The original formula was reduced by 2. If we got a 4, the original formula would have been reduced by 4. Now, what do you suppose the most common number to get there is? It is a 2. Most formulas, if they've been reduced, are reduced by a 2. Not all. You can even get as high as a 6 or a 7. However, 2 is the most common. So now we take the 2 and we multiply it through the empirical formula. Well, what is the empirical formula? P2O5. So, what do we get when we multiply it through? That is your answer. Now, let me caution you, because every year people do this dumb mistake. Every year, in every class. Somebody here will do it. I hope not. Exactly. Every year, somebody gives the answer, and they go, dang, I got to reduce. I got 4 to 10. Now, the point of the question is to get the answer back to what it was before you reduced it. If you reduced it, you just wiped out your work. So try to hold back and don't reduce it. Okay? It was reduced here. Don't reduce it. Okay? Not all of them will be a 2. Okay? What?
Okay, you said because the original formula was always usually the common thing is 2. Is that because it's all the elements mostly acidic?
No, a lot of them have oxygen and sulfur in them, and oxygen and sulfur is oxidation number 2. And so a lot of them get reduced by 2. For example, if we did this one, all right, just as a quick sample to illustrate a difference. CNH is your empirical formula. You have 78, right? So 78 divided by, if we add up C and H, C has a 1, H has a 1, mass is 12, mass is 1, 12, 1 for a total of 13. 78 divided by 13 is 6. 6 times CH is C6, H6. So they're not always going to be a 2. Okay? But a lot of times they're going to be a 2. Okay? All right, last question. Write that one down. Last one. This will be like your last tomorrow. And you need to make sure you're homework. This will be on the worksheet I gave you last week. Why?
I think so. He said I got 4. And I'm thinking that's the 4.
Oh, yeah. Yeah, I found what?
That was pretty good, but.
Yeah, for that, for your first time.
But the first, you said himself, I had a 14.
Oh.
I got an 8.
Who wants the breakfast special story?
Me,
Yeah.
Daniela.
Thank
John
you.
Black.
All right, I heard Danielle and Dr. Jones.
Hard.
No,
Oh, both of you.
All right, I heard Catherine and Queen. So, he said, so then he picked her up. Ooh. Don't walk up here and get it. Just laying on my desk. Well, you need it. Or not say probably need it, not you. Write it out. Anybody else?
You want us to solve this?
You can get started on it. No. Anybody else? Want one? Anybody else?
No, I don't know how.
Okay. So, what are we gonna do first?
We are going to write.
Yeah, because you don't have the empirical formula this time. So you have to do the empirical formula part first. So what we start with earlier today, we took the percent off at Jason's what? Okay? So after we changed it to grams, what'd y'all do then? That was hydrogen on with carbon. You did what? Char, and you changed it to what? Okay, let's change it to mole. What goes beside mole? Okay. And carbon's mass is 12, hydrogen is 1. And I'm just using whole numbers at the moment. Because it's not really going to change our answer.
Yeah, I know the common element. But I know them.
Alright, so once I get moles, what do I do then? What do we do next after we got moles?
Divide by the smallest number.
Okay, divide by the smallest. I have no idea. Alright, so I get 1 and 2.01. So what do I do with those numbers? Okay, so I've got C with a. Now, when I get that, really? Y'all can't put that thing on silent? Now, that's the empirical formula. That's right. That's the empirical formula. Now, that's only half the question tomorrow. What do we do with where's that? Right here, the 48 or 42.08. What do I do with it? Now we have to do the second half of the question. So I have to take the 42.08, which is the empirical form or the molecular formula mass, and I have to find the molecular formula by taking the what now? The empirical formula. Well, I have to take the CH2, and I have to do what with it? Find its mass. I got to add it up. So how many C's do I have?
1,
How many H's do I have? So times 12 times 1. So I get 12. I get 2 for a total of 14. 14 like 14. Where do I put it? So 14, or 42 divided by 14 is 3. So this tells me that this formula was reduced by what? Reduced by 3. So now, what am I going to do with that 3? That's right. So 3 times CH2 becomes C3H6. Exactly right. Okay? Now, you remember that sheet I gave you last week? It looked like it was photocopied out of a textbook.